We are recording Tuesday, March 22nd, WSSB geometry class. We are on section 9-4 titled Proportional Parts and Triangles. It begins on page 368 in print and
Braille page 46.
Braille page 46. Thanks, Justin. Let me turn my camera on just in case. All right. So before we get started, we're kind of doing the routine of just kind of going over the objective of the lesson and discussing what you may already know or think you know about the objective. And the objective of this lesson, or what you're supposed to learn, is to identify and use the relationships between proportional parts of triangles. So identify and use the relationships between proportional parts of triangles. We kind of think about that, like proportional parts of triangles, and what you've already learned about proportions, about similarity, about triangles.
Because we know like that the sides are proportional.
Okay, you know sides are proportional, so maybe that's going to tie in here. All right, what else?
You can use your tests, like your angle.
We're probably going to use our tests, like angle, side. No donkey, right? Side, angle, side, though, right?
Side, angle, side works.
Yep, we could do those.
Yep.
Right. That's a good start. That's not all of it, but that's definitely a good start. And in order to discuss this, you need that information in order to do this section.
I'm sure you would.
So let's take a look at where it starts in print or in Braille. It says in triangle PQR. So in EDT PQR. Sure, Tabitha.
So in triangle PQR ST.
Oops, scared. Excuse you.
I told you I didn't.
Bless you.
Okay.
ST.
Okay. In triangle PQR ST. Something
parallel.
Oh, parallel. Okay. Parallel to QR and ST intersect the other two sides of angle PQR.
Triangle PQR.
Note the shape of triangle PST. Are PQR and PST similar?
All right, so we got to go look at a drawing. So you want to do the next page, all right? And I'm going to utilize my book. What did you say was on Braille page 47?
That would be on page 47
in
Braille,
I'm going to use the mic since I have a Braille book available to me.
Good.
So I'll draw over this drawing for the recording. Okay, so we have the triangles that they're talking about. They have the big, huge triangle PQR. P's at the very tippy top. Q is down at the bottom left.
Oh, I see that.
And R is the bottom right vertex. So there's a huge, or not huge, but a big triangle. Okay? That's the one they're talking about. Then they told you that their ST, so line segment ST, is parallel to segment QR. So straight above the base QR, in the midst of the triangle, is segment ST. And they're saying, note that the shape of PST, so if you just start at P and come down to S and go directly across to T and back up to P again, you have another triangle, don't you? So by putting a line parallel to QR,
you do have that a little bit.
Now they said, are PSR and PST similar? Well, how can we prove some similarity? What similarity test could be used? Justin, you said, I think we're going to use our similarity tests. Our similarity tests are what?
Angle.
Angle.
Side.
Side, angle, side.
Side, angle, side.
I must have said angle, side, angle.
Yeah. They didn't give us any side measurements to zero in on. I mean, we probably figure them out in a roundabout way. But we could think about the angles, couldn't we?
Mm-hmm.
So we should see if angle-angle works.
Yep.
Well, if we have triangle PQR and triangle PST, what is the most obvious angle?
The P.
The P, exactly. Both of them share P, so we've got one angle that they share, right?
Mm-hmm.
Now, notice that they've labeled at S, they've labeled the interior angle a 1, and at Q, they've labeled the interior angle a 2. And this is really important for us to look at.
Mm.
If you imagine ST extending into infinity to the left and the right, and QR extending into infinity to the left and the right, we've got two parallel lines, don't we?
Yeah, we would. Yeah.
What is PQ to those two parallel lines? The whole side PQ, what would it be? What would that be to those two parallel lines ST and QR? What would we call that PQ?
T.
Starts with a T.
A transversal?
It's a transversal, isn't it?
Yeah.
And so if you consider that PQ is a transversal, angle 1 is on the outside of the parallel line, and angle 2 is on the inside of the parallel line. What are angle 1 and angle 2 to each other? What are they called? They're on the same side of the transversal, but one's on the outside of the parallel line and one's on the inside of the parallel line.
They're
Collinear?
no.
They're not
Oh, yeah.
collinear.
They're
They're not consecutive
I was about to
because
say
they're not one
consecutive.
after the other, but you're on the right track. They start with a C.
They're
They're corresponding.
corresponding.
Oh, wow.
Good job, Tabitha. You're smiling. You're like, yeah, I remembered that.
I remember something.
I know-
One's on the outside, one's
I
on
knew
the
it was
inside.
something.
Yeah. And
But
what
I
are
couldn't think.
corresponding angles? What are they to each
They're
other?
congruent.
They're congruent. So did we just prove that angle 1 and angle 2 are congruent to each other? Yeah.
Yes.
Right? So
Yep.
one of the angles, that bottom left angle of PST, is congruent to the bottom left angle of PQR.
Yep.
So do we have angle now?
I believe we do. Yep.
We do. Exactly. And then of course angle T would be congruent to angle R,
Mm-hmm.
right? Because of the same reasoning, corresponding
Mhm.
angles, or angle sum theorem.
Yep.
So we just proved that angle 1 and angle 2 are congruent because they're corresponding angles. Therefore, angle P is congruent to angle P in triangle, and the angle 1 and angle 2 are PST and PQR congruent.
Yep.
We got angle-angle similarity.
Yep.
So we know these two triangles are congruent. So therefore, now we've
Don't you mean
created a
similar?
new theorem, haven't we? They're not congruent. I mean similar. Thank you so much. You're right. They're
I
similar.
was like, wait a minute.
Now, because we put this parallel line through a triangle and did this and used our parallel line transversal information, our angle-angle similarity, we just figured out through deduction an if-then statement, or the next theorem. And the next theorem is, if you turn the page, on the next Braille page, 48.
Uniform, seriously.
In
That's their
words, do
phrase.
you want to read the words, Tabitha?
Sure.
Okay.
Words. If a line is parallel to one side of the triangle and intersects the other two sides, then the triangle formed is similar to the original triangle.
Ta-da! We just proved that, right? We said, well, if you put a line through my triangle parallel to any one of the sides, and it intersects the other two sides, doesn't matter where it intersects, as long as it's just parallel, you've created two parallel lines, you've created transversals,
Mhm.
so therefore you've created angle-angle similarity, and you know that the two triangles are going to be
Yep.
similar. The little triangle is going to be similar to the big original triangle.
Mhm.
Always, 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 always.
Cool.
So then we know that it's always proportional. So if you take a look at
Besides.
the drawing for this theorem, they have a big, huge, obtuse scalene triangle. A,
Yep.
D, and E is the big triangle. A is the top vertex. D is the bottom left, and E is the bottom right. And then they have a segment BC parallel to DE going through the midst of our triangle, and they have little parallel indicator arrows on them.
Yep.
They're saying that ABC, the little triangle at the top now, is proportional to the big triangle ADE. And we know that because of AA, and now we know it because of the theorem, this theorem 9-4. If we've got a parallel line to one side, intersects the other two sides, then we have the triangle form is going to be similar to the original. If we know that, then we know that corresponding sides are going to be proportional. So AB of the little triangle is the ratio to AD, isn't it? Does that make sense?
Yep.
And AC, the right side of the little triangle, what would it be proportional to the big triangle?
I bet. DE?
AE. So look at AC on the right.
Yeah.
That would be compared to AE.
AE,
okay?
my bad.
And then the bottom of the little triangle, BC, would be ratio or proportional to DE, right? Okay. So if they gave you any one of those measures, you could set up your proportional statements. Do the product of your extremes has to equal the product of your means. Do a little algebra. Bang, you figured out the missing variable or side. Okay? Which is exactly what we're going to do.
That's what we've kind of been doing.
Okay, we have been doing it, but now we get to look. What I like about these is it's not two triangles suspended in space on the paper.
Yeah.
It's very simple when you have two triangles like this formed with a parallel line to know which sides correspond with which sides, don't you? AB corresponds with AD.
Yeah.
Because they're in the same orientation, aren't they?
Yeah.
Okay? All right, so let's go take a look at the next drawing and the next problem. It's example 1 on Braille page 49, print page 368, or C368.
Yep.
So we have to complete the proportion SB is to SR as question mark is to RT. That's what it says up above. It says complete the proportion SB over SR equals question mark or blank over RT. You see that? And they give you the tactile to look at, and pretty decent looking triangle. They're going to run a parallel line through.
Yep.
The very top vertex is R. Bottom left vertex is S. Bottom right vertex is T. Going through the midst of the triangle from side RS is B, W. And they have parallel line indicators, so it's parallel to the right side RT. See that? So this shows you a drawing that you don't have to have a parallel line going through it in relationship to the bottom of your page. You can have a parallel line going through in relationship in parallel to any side, so this one is at an angle from like about 10 o'clock to 4 o'clock. You see that? So it's created a triangle SVW, S to V and back to W, the little triangle, with the big triangle SRT. You see that?
Okay.
Okay. So it's saying SV is to SR as blank is to RT. So what side would we put corresponds with RT? So look at your little triangle. Which side corresponds to RT? In the same orientation.
Well, I read that off VS.
Not VS, SV corresponds with SR, or you could say RS corresponds with VS. What corresponds with RT? The side on the right of your big triangle What matches it on your little triangle?
VW.
VW.
Okay,
Good.
I just looked at it wrong.
Did you find it? So, Justin, you've got R to T on your big triangle, and then you've got V to W on your little triangle. Find it?
Okay.
There you go. No, stay in the middle of your triangle. Follow that line up. So all the way up to find V. There you go. Right there.
Okay.
So V to W, go back down to W. There you go. That one corresponds with RT.
Yeah.
So go all the way over to R at the top.
Yeah.
All the way up to R at the top, and back down to T at the bottom right. Okay? So those two sides correspond with each other.
That would make sense.
Okay? And what's really nice with these triangles is one is inset in the other. So they're in the same orientation. They're not upside down and backwards or anything to each other. Okay?
Yeah.
All right.
I get it.
So if we use the same triangles, complete this proportion. ST is to SW. ST is to SW as SR is to
Blank. ST is to SW.
TV?
S.
What is that?
No, ST at the bottom, the big side at the bottom. Is to SW, the little side at the bottom, right? As SR, the big side on the left, is to
RT.
no, that would be the right side. SR would not be corresponding to RT. They're a part of the same triangle. SR is your left side of your big triangle. What's the left side of your little triangle?
I'm looking at. Oh.
Same side, same orientation. Where's your little triangle? What's the left side of your little triangle? Start down at S. Go up to the next point.
V?
SV.
Oh.
And go from V to W. So go down through your triangle to W and back to S again. That's your little triangle. SVW. Your big triangle is SRT. So if they're comparing big to little, so they're saying ST to SW, then they're going to compare SR to SV.
Okay.
And then they would compare RT to the right side of the little triangle. VW. Good. Okay. So be really careful that you understand the orientation of those. They're comparing big to little, big to little, big to little. The last time we practiced it, they compared little to big, little to big. Same orientation. They haven't been rotated. They've just been scaled down. They've stayed in the same position. So they share segments, don't they? They share lines. SR shares the line SR with SV. Okay?
Yeah.
So left to left, right to right, bottom to bottom. Okay?
Yeah.
Let's turn the page and take a look at the next drawing. Now we're going to do a little solving. This is where it ramps it up a little bit. Really concentrate on this. Take our time. It's 10:30, by the way. I'm watching the time. All right. It says in the figure up at the top, it says example 2 algebra link. In the figure, JK is parallel to GH. Find the value of X. So we've got to go really explore this tactic. It's going to get a little bit confusing, so we want to be really careful. So up at the top vertex is H. They've labeled that off to the right. And the bottom left vertex is F. They've labeled that just above the point. The bottom right vertex, they've labeled to the right G. So the big triangle is HFG. You go top to left to right. Then in the midst of the triangle at an angle, and the orientation from about 10 o'clock to 4 o'clock, they've labeled a point K on the left side. They go through the triangle to point J at the bottom. And there is a parallel indicator on KJ, or JK.
The little arrow thing?
The little arrow thing.
Okay, I didn't know.
And it's parallel to GH, the little arrow arrow indicator on the right side of the big triangle,
Oh,
GH.
oh yeah, yeah.
So you know, plus in writing, they said they're parallel, right?
Mhm.
And in the drawing, you know they're parallel with the little parallel indicator. Okay?
Right.
All right, now, we got our two triangles. We know they're similar because of our theorem, right?
Yeah.
Parallel side, parallel line, to a line parallel to a side. So we know that KFJ is parallel, or similar, excuse me, to HFE. Now, they give us some measurements. Back up on the left side from H to K is 3 units, and the 3 runs into the side, so it might be hard to see. So find the number sign, and then it's supposed to say a 3 there.
I see
Okay?
3.
H to K, 3. K to F is 6 units.
Yep.
Okay? Down at the bottom, F to J is 8 units. And then the entire F to G, they've arrowed off, they've traced off, and they put an X. So the whole F to G is an X. The F to J is an 8. We have to figure out what X is.
Yep.
So we're given these triangles have a parallel line, right?
Yep.
So we know that they're similar to each other by Theorem 9-4. We get to tell that to the court. Well, Judge, I know that these two triangles are similar to each other because you gave me that KJ is parallel to HG, and I know by the angle-angle similarity postulate and the theorem that states if a line's parallel to one side and intersects the other two, then the two triangles formed are similar. So I know they're similar. I know they're proportionate. The sides are going to be proportionate. So I'm going to set it up. I'm going to set up my little triangle side on the left is a 6 compared to my big side on the left. How much is my big side on the left? 8 H to F. How much is that?
I think we said it was 8
That's
units.
No,
Oh,
H to F.
Oh, yeah, yeah.
We got to do K to F is to H to F, right? Left to left. K to F is 6. How much is H to F? H to F is 3?
Well, I'm looking at H to F. It looks like 6.
Okay.
H to 3 looks like K. Or
H to K is 3. All right, so how much is H to F? K to F is 6.
Oh.
H is at the top, F is at the bottom left. How much is the entire left side of the big triangle? 9.
Oh, yeah, okay.
Okay, so 6 is to 9. The left side of the little triangle, KF, is 6. The left side of the big triangle is 9, and you had to add those two together. So 6 is to 9 as, or equals, right? 6 is to 9 equals 8. That's the little, that's the bottom of our little triangle. F to J is H. And F to G is what? X. So 6 over 9 equals 8 over X. How do we solve that?
Well, first we got to cross multiply.
Okay. What are our extremes?
6 and X.
6 and X. All right. So we got 6X.
6X.
What are our means?
8 and 9.
9. 8 times 9 is
74?
72.
72. I always do
So
that.
6X equals 72.
So
Now what?
72 divided by 6 is 12.
Divide.
12. Good.
Yep.
So X is 12. And if we wanted to check it, we could substitute back in and double check. 6 times 12, yep, 72. 8 times 9, 72. Okay?
So they are proportional.
Yeah, they are. Well, we knew they were proportional because of the definition of similar polygons, right? And that postulate, well, the theorem, our angle-angle postulate, and then the theorem that says, well, I've got parallel lines. So we're not proving similarity.
Yeah.
We were given that basically because they told us that KJ is parallel to HG. But what we wanted to find is the value of X. So we were able to say, well, because they're similar, I know the sides are proportional. I can just solve this simply with a proportion problem. 6 is to 9 as 8 is to x. Cross multiply, 6x equals 72, divide by 6,
Yep.
x equals 12. Okay?
Yep.
Make sense?
Yep.
All right.
What
let's
are
do it
they
again.
making next door at DL?
I don't know. It smells good.
Yeah,
I can't smell
Can I
it.
have the tissues, please?
What's that? Tissues. Yeah, hold on.
I don't smell it.
I hope.
All right, turn several pages to page 53. They're page 53. It's
That was
D369.
58. My bad.
We're going to do another one of these.
59, 58.
58 you said, or 53? In Braille.
Let me look again. 53.
53, okay.
Okay,
Tissue
yeah.
box go back here.
I think someone stole it.
Oh, there it is. Moves around.
That would be D379 in white and print.
D369.
Or 69, my bad. I read that wrong. I read that as a 7 for some reason.
10:35, by the way.
I'm keeping an eye
Curious
as well.
about the time. All right, so we have another figure that we're being told that segments are parallel to each other. Here
Cool.
It says up at the top of this page, in the figure, segment AB.
Oh, it says your turn too.
Yep. Segment AB is parallel to segment PR. Parallel is EDL. Okay. So we've got to find the value of x. This is going to be a your turn similar to the last problem. So at the very top of your large triangle is vertex P. The bottom left is vertex R. The very bottom right is vertex Q. There is a line going parallel to PR, so find PR on the left and move into the triangle and find the line parallel AB. Find it? It has parallel line indicators. So you have your big triangle, and then you move into your triangle and find AB, and you have a little triangle, ABQ. Do we know, without a doubt, that these two triangles are similar to each other?
Yeah, because of the parallel line theorem.
Yes.
If you want to
Parallel
call it.
line theorem and the angle-angle similarity, boom. So we know those are similar. They told us from P to R, they right next to the left of that parallel line indicator, that's 8 units.
Okay.
AB, right next to the parallel line indicator, is 4 units.
Okay.
QB or BQ, the base of the little triangle, they're telling us is 5 units.
Oh.
And the entire R to Q is X units. What is the value of X?
Okay.
So what proportion would you set up here?
Yeah, let's see. Let's see.
Got a good start. 8 is the
8,
what?
8 over 4
Mm-hmm.
equals 5 over x.
Good. No, nope, careful.
Oh.
X over 5?
Yes.
Oh,
Why is it
okay.
X over 5? Why did you correct that, Tabitha? You did a good job. 8 is to 4 is X is to 5.
Sorry, Marita. Because that X usually is 96.
Well, no. Think about your proportions, your corresponding sides. If you go from big side to little, big triangle to little triangle,
right.
do you have to set up your other proportion, your other ratio the same way? So X to 5.
Yeah.
If we would have said 5 to X, Justin, we would have been flipping it and saying little to big, and that's going to end up in a mess, right?
Yeah.
So if you wanted to say 4 is to 8, then you would say as 5 is to X.
Oh, I get it.
You get it now? Okay. So what is X? 8 is to 4 as X is to 5. What's X?
So I got to plus multiply.
Okay.
So 4 and X are extremes.
4X, okay.
So that would just be 4X.
Okay.
So then we do 4.
8 times 5?
8 times 5.
Or 8 times 5,
40,
my bad.
Okay.
Divided by 4 is 10.
10. And let's think about this common sense-wise. 8 is to 4 as 10 is to 5.
You can reduce that.
You can reduce it. Right, exactly.
You can divide by 2.
2, yeah.
And
So they
get-
both become
and get-
2's, don't they?
Yeah.
2 equals 2. Yeah,
Yeah.
it's double. They're 1/2 or double, right?
Yeah.
Okay.
No, that's,
All right.
That
Good.
totally works.
Works, yeah. So sometimes you can set up a proportion, or sometimes you might just even notice that it does that.
Yeah.
Now,
You just know, oh, that looks like it could be reduced, or oh, that looks like it's proportional.
Now, goes through several pages of an activity with that people would draw a bunch of stuff. We're going to move our way all the way to Braille page 59.
What print page?
Print page 370.
Oops, I almost went to 70 something.
E370.
59.
Mm-hmm.
I like using the Braille pages, that's easiest.
E370. They went through an activity to say, well, Theorem 9-4 says, up at the top, if a line is parallel to one side of a triangle and intersects the other two sides, then it separates the sides into segments of proportional lengths.
Yeah.
Well, that would make sense. If we're creating proportional triangles using sides of triangles, then it would make sense then, and we deduce that we're going to create proportional segments also. So in other words, what they're saying, take a look at the drawing.
Isn't that kind of what we were just...
It was, but we were looking at sides. Now we're going to look at the segments rather than the sides.
Okay.
So we have A at the very top vertex, D at the very left, bottom left, and E at the very bottom right.
Oh, you're right, okay.
And then there's a line parallel to DE that they've labeled BC. So we have a triangle ABC at the top and the big triangle ADE. What they're saying is that on the left-hand side, AB is proportional, is in ratio to BD. They're proportional. AB is to BD as AC is to CE. Is that cool? Yeah. So if you're just given maybe AB is 2 and BD is 3 and AD is 4, you would be able to figure out CE. You could do 2 is to 3 as 4 is to X.
Yeah.
And then do your cross multiplication and division. Okay? So parallel lines, parallel segments in these triangles create similar triangles. They also create proportional segments, which is really cool, which helps us to do the math that we need to do, which is going to be on the next one. So let's use this theorem on page, we've got to flip several pages to 371, D371 or Braille page 63. Okay? D371 or Braille page 63. So read up at the top. Algebra link, number 3. In the figure, RS is parallel to UW. Segment RS is parallel to UW. Find the value of X. So we're going to go take a look now and apply this new theorem, this new knowledge that we have deduced about parallel segments in our triangles to figuring out a missing variable or a missing measurement. So you have U at the very tippy top vertex, V at the bottom left, and W at the bottom right.
UVW.
UVW. If you go parallel to UW at the right and move into your triangle, you'll find a little segment RS that runs parallel to UW. So it's creating a very tiny little triangle, RVS. We know that RVS is similar to UVW. We also know now from this new theorem that this parallel line split up our sides into proportional segments, didn't it? So UR is to RV as WS is to SV, isn't it? Or vice versa. VR is to RU as VS is to SW. Does that make sense? Okay. They gave you some measurements. They told you that from V to R is 4. from R to U is X.
Mm-hmm.
From V to S on the bottom is 5. And from S to W is X plus 2.
Oh.
Oh.
This is where we got to do some distribution.
Do a little distribution. Good call, Justin. Make my math art pitter patter.
Yeah.
All right, so we're going to set up a
Thought I could
proportion,
do
aren't
that.
we?
Mm-hmm.
So 4 is to X.
Yep.
So 4 over X equals. What are we going to put? 5 is to?
5 is to X plus.
Yeah, X plus 2.
Yeah.
Good. So you're going to have 4 over X equals 5 over X plus 2. So your extremes are 4 and X plus 2.
Mm-hmm.
What's your distribution on that? What's it going to be?
4 times X is 4X. 4 times 2 is 8.
Good. 4X plus 8 equals?
Yep. 4X plus 8. So
4X
now
plus 8
we
equals,
gotta.
and then what's your means? 4 over X equals 5 over X plus 2.
It would be 5.
5X. Yeah.
And X. Yeah.
5X. So you have 4X plus 8 equals 5X. Do we have variables on both sides of the equation?
4.
Yep.
Yeah.
So we want to move that 4X over. As Hodge says, move it across the street, right? So we're going to minus 4X from both sides.
Right.
So we get 8 equals, what's 5X minus 4X?
That'd be
X.
Oh, yeah.
X.
5X minus 4X is X.
Mm-hmm.
And we're left with an 8. 8 equals X. We're done.
Yep.
Bam. So then we can plug that back in.
Yep.
We know that our U is 8.
Mm-hmm.
And then SW would be 8 plus 2. So that would be a 10, wouldn't it? So we check it. 4 is to 8 as 5 is to 10.
Mm-hmm.
That sounds about right. We just did something like that earlier, didn't we?
Yeah.
Okay. So this takes a little bit of effort.
Yeah.
You have to use the distributive property, as you said, Justin.
Yep.
Then you have to move your variables across the street. You got to cancel them out on one side of the equation. So having 4x plus 8 equals 5x,
we
couldn't have them on both sides. So we went, well, let's get rid of the 4x on the left by minusing 4x. Use our subtraction property of equality. We minus 4x on both sides.
Yeah.
We're left with an 8 on the left equals, then 5x minus 4x is x.
Yeah.
So we don't even have to do the division property. We're done.
Right. Well, yeah, because there wasn't really much division.
Okay. No. If it was like 2x, we would need to divide.
But yeah.
Okay. All right. Does that make sense?
I think this is making sense, yeah.
Yeah. A lot of information. So now when we go back and kind of check what you know about identifying and using the relationships between proportional parts of triangles, what would you say now that you've learned?
Probably a lot.
Okay. Well, give me some details. Like, what have you learned?
Well, like the parallel line theorem. I didn't really think about that. Like,
yeah.
That if you have two parallel lines, and crap, I can't say it exactly.
Well, if you have a line parallel to a side of a triangle, it creates what?
It creates a segment. No,
it does create segments, right? And those segments of the sides become what to each other?
They become proportional.
They do become proportional. What does it also create? When you take a parallel line through a big triangle parallel to any side, what else does it create? Your big triangle becomes... Is it still just a big triangle, or did now you create something else?
Didn't you split it?
You split it. You make another triangle. And what are those triangles to each other?
Proportional.
They're proportional. They're similar. Yeah, good. So the parallel line does two things.
That's interesting.
The parallel line to any one side, we know by parallel lines and transversals and all we learned about that, creates an angle-angle similarity. So we know that the little triangle is going to be similar or proportionate to the big triangle. We also learned and figured out that, if it creates that proportionality, then also it's creating proportional segments of each side.
Yeah.
So the little segment is in ratio, the ratio of the big segment, and proportional to the little segment and big segments of the other side. So we can use that to solve for unknowns if we're given the measurements of those segments or sides. Okay?
Yep.
You could also say, yeah, 4 is the same as 4 to 4 over 4 plus x is the same as 5 over 5 plus x plus 2, right? We could solve it that way. We could go a roundabout way and get it that way, but we now know we don't need to do that, and we could just say, oh, well, little segment is to big segment as little segment is to big segment. Cross, multiply, divide. Remember to use your distribution property. Okay? Okay. We'll do a bunch of review of this tomorrow also and a bunch of practice, okay?
Sure.
I am going to turn off the recording now. And I would advise anybody that has the textbook at home and is following along that you do the check your understanding on page 372 to 373, number 1 through 30. All right, signing off on this report.